Hey everyone, if you've ever written even a single line of code, you've probably hit this classic crossroads. When your program needs to make a choice, do you go with an if statement or do you use a switch? It sounds super simple, right? But the choice you make can actually matter. So today, we're going to settle this debate once and for all.
All right, let's just dive right into it. We're putting these two fundamental coding tools head to head. I mean, how do they really work under the hood? Is one actually faster? And of course, the big one. Which one should you be using and when? Let's figure it out.
Okay, but before we can even compare them, we have to get on the same page about what they're even for. Think of them like a compass for your code. Seriously, without them, your program just runs in a straight line. But with them, it can actually navigate complex paths and, make smart choices.
So how does code even make a decision? At its very core, programming isn't just about following a list of instructions from top to bottom. That's boring. The real power comes from asking questions and then choosing different paths based on the answers you get. That's what makes software feel alive and interactive.
And this whole process, this secret sauce, it has a name. It's called control flow. It's what lets a program adapt and react to different situations. Without control flow, every single program would do the exact same thing every single time you ran it. The tools that let us direct that flow, well, those are our decision-making statements. All right. Let's kick things off with the most famous, the most fundamental decision-making tool in all of programming, the if statement, and of course, its very useful relatives.
The if statement starts out super simple. It's like a bouncer at a club. It just checks one condition. Is it true? Cool, come on in. If not, you're skipped. But then it evolves, right? You get if-else, which gives you a fork in the road, a clear choice between path A and path B. And then you have the whole if-else-if ladder, which is like a whole series of checkpoints, perfect for when you need to check multiple different things one after another.
Okay, now let's bring in the challenger, the switch statement. This one's a little different. It's not a general do-everything tool. It's more of a specialist, designed for a very specific kind of job.
So unlike that if ladder, which can check a bunch of totally different conditions at every step, a switch statement is laser-focused on just one thing, a single variable. It takes that variable's value and then compares it against a preset list of possibilities, what we call cases, looking for an exact match. It's all about that one variable.
And this slide just illustrates the difference perfectly, doesn't it? On the left, you've got the if-else-if ladder, and it reads kind of like a series of questions. Is the score 90 or more? No. Okay? Then is it 70 or more? You have to read it step by step. But now look at the switch statement on the right. It takes one value, the score, and just gives you this clean table of contents. It maps values directly to outcomes. It's just so much more structured, more organized, and honestly, a lot easier to see what's going on at a glance.
So this is the big question. Which one should you actually choose? And it's not just about what looks prettier. It's also about performance. To get the real answer, we've got to pop the hood and see how the computer actually handles these two different structures. Okay, now this is where it gets really interesting. There's a fundamental performance gap here, and we can talk about it using a little computer science concept called time complexity. The if-else ladder, it's basically a linear search. It checks condition 1, then 2, then 3, so the more else-ifs you add, the slower it can get. We call that O of n complexity. But a switch statement, oh, this is clever. The compiler often optimizes it into what's called a jump table. That means it can go directly to the right answer in a single step. That's O of 1, or constant time complexity, and that is incredibly fast.
And hey, this isn't just some academic theory. As this developer on Stack Overflow points out, once you get to about 5 or more cases in your switch, the compiler often does this little magic trick. It builds that lookup table behind the scenes, so finding the 10th case takes no more time than finding the very first one.
But, and this is a huge but, here comes the reality check from another developer. Yeah, switch is often faster. But we're talking about nanoseconds here, a billionth of a second. Unless you are deep inside some high-performance game engine or a critical system loop, this tiny, tiny speed difference is almost always completely irrelevant.
So what's the bottom line here? The verdict is, yeah, switch is often faster on paper, but in the vast majority of real-world apps, that difference is so small you'd never notice it. So the real wisdom, the pro move, is this. Prioritize what makes your code easier to read, understand, and maintain. The real performance problems in your code are rarely going to be an if statement. Focus on your bigger picture, your algorithms. Optimize for the human who has to read your code next, not just for the machine. Okay, so with that philosophy in mind, clarity over cleverness, let's get into some practical pro tips and a few of those classic traps you'll definitely want to avoid.
For those really simple this or that decisions, there's an even shorter way to do it, the ternary operator. It lets you write a whole if-else statement on one single elegant line. Like, imagine setting a user status. Status equals is logged in to online, then offline. See, super clean for simple assignments. Just be careful. If you start nesting them, they become an unreadable nightmare fast. All right, another really key concept to get your head around is short-circuiting. It's basically a form of logical efficiency. Think about it. If the computer is evaluating A and B, and it sees that A is false, well, it doesn't even need to check B, right? The whole thing has to be false. This is great. It's an optimization, and it can even prevent errors. But it can also bite you if you were actually counting on something happening in that second part of the expression that now never gets run.
Now for a classic old-school programming puzzle, the dangling else trap. Just look at this code snippet. We have an if nested inside another if. The question is, where does that else belong? Does it pair up with the first if or the second one? The way it's indented might trick you into thinking one thing, but the compiler, it might see something else entirely.
So the language itself has a rule for this. The else always pairs with the closest if that doesn't already have one. But trying to remember that rule is risky, and it makes your code a nightmare to read. The real pro solution is simple. Always use curly braces. Just do it. They act like parentheses, making the structure of your logic totally explicit. There's zero ambiguity for you, for your teammates, or for the compiler.
And this brings us right back to our big overarching question. We've seen that switch can be faster, but the real lesson here is that raw speed is just one tiny piece of what makes code good. The best code isn't just fast, it's clear, it's easy to maintain, and it's predictable. So the next time you're facing this choice, don't just ask yourself which one is faster. Instead, ask which one makes my intention here crystal clear, because that is the question that leads you to writing truly great professional code.